this one is more powerful than you think. So since we have a lot of time this semester in the second half of the semester, my intent is to do a very thorough treatment of this thing, more than we usually offer. All right? Because a lot of you are going into engineering. If it is so, you're going to see this on a daily basis. You know, physicists, you do this on a daily basis. And even if you don't consider the convergence issue, you know, because in some of the application situations you don't even know whether it is convergence. But even at the formal level, it turns out to be extremely powerful bookkeeping tool. Extremely powerful bookkeeping tool. So the infinite series concept appears not just in calculus, but it can be used without touching on convergence issue. Just to use that form as a, you know, just a symbolic object can be used to pack a lot of useful information all together. Like over here, I packed all these information all together into one object, one mathematical object called a series. That series in X. And that series in X, you can manipulate it. If you have two series of such, you can multiply them together and do all sorts of operations. And then that means that you all of a sudden you have a lot of pieces of information. They are interrelated, and somehow you know there's got to be a lot of relationship among them. And if you pack them all together into a series, and somehow the arithmetic operations of a series somehow encode a lot of relationship among all those pieces of information that you use to pack into a series. All right, so it's an extremely powerful tool, not just in calculus. And that's why you have to pay attention, you know, to this chapter. It's an extremely important chapter, which unfortunately oftentimes, you know, it's relegated to the last 3 weeks of the course, right? Which is kind of a shame, but sometimes it just so happens. The first 2 times I taught calculus 2 is was